You know it's going to be a great day whenever you have to use Laplace transforms. So here we have the integral from 0 to infinity of e to the negative t cosine squared of 3t with respect to t. And this is basically the Laplace transform of this function right here, which is something that a lot of people use in differential equations. But let's go ahead and solve this particular integral right here. It's going to require some integration by parts, and we have to use a power reducing formula for cosine squared. So how do we go about it? Well, don't forget, cosine squared is 3t. This is going to be 1/2 times 1 plus cosine of 6t. This is basically the power reducing formula where this right here, whatever this value is, it's going to be 1/2 of 1 plus cosine of that double value right there. And now that we have that, it's going to make our integral so much easier because it's going to become the integral from 0 to infinity of e to the negative t, and then we have 1/2 times 1 plus cosine of 6t. And let's just go ahead and make sure we have all these parentheses aligned. All right, let's go ahead and move this 1/2 to the outside. So we really just have 1/2 integral of from 0 to infinity of e to the negative t times 1. So that's e to the negative t. Let's go ahead and put this inside of parentheses here so people don't get upset about that. Let's go ahead and distribute this e to the negative t to this part right here, and that's going to give us plus e to the negative t cosine of 6t with respect to t. So we really have two things to solve. We have this integral right here, and then we have this one right here. So let's go ahead and talk about this one. Well, I mean, that's just a basic u substitution. This is 1/2, and this is negative e to the negative t, and you're implementing the first fundamental theorem of calculus from 0 to infinity. Now, I know that I should put a limit here, but I'm just avoiding that. We just go ahead and plug in infinity, quote unquote there. All right, so when we plug in infinity, e to the negative infinity is just going to be 0, so that's going to go away. So we really just have 1/2 times 0 minus negative e to the 0. So in other words, plus e to the 0, which is going to be 1. So we really just have 1/2 right there. That's awesome. Now we have to deal with this integral, which is 1/2 integral from 0 to infinity of e to the negative t cosine of 6t dt. Now, I have something for you. I want you to work out this integral right here. I want you to do this on your own and figure out why or how this is equal to 1 over a squared plus 1, where your a value is in the input of cosine. So knowing this, and I'm just, again, this is going to be a challenge for you, that is going to be used for this right here. Well, my a value in this case is 6. So what we really have is 1/2 times 1 over 6 squared. In other words, 36 plus 1. That's going to be a 37. So this is going to be 1/2 times 1 over 37. And guys, we can go ahead and implement this, or we can simplify it very easily by making it 19 over 37, and we are done. That's pretty neat.